Yeah, thank you very much. I'm Pat Crowley, founder of Chapul, which is the first company in North America to introduce insect protein in a consumer packaged product. But taking a step back before that, I was working for the Arizona Department of Water Resources as a hydrologist, and my very first project was to quantify the agricultural consumption of the Hopi Native American reservation. Agronomists, and this photo shows their Hopi corn. And this is a very resource scarce environment, very arid, high winds, but also high elevation, so subject to harsh winter and freezes. And they have, within the Hopi reservation, there's the longest continually inhabited settlement in all of North America. It dates back more than 1,000 years. And I know that that's an order of magnitude less than continually inhabited settlements in this part of the world, but for us in North America, that might as well be an eternity. They represent a very highly adaptive culture, as well as integrated to the plants that they're growing. The Hopi corn shown here has an elongated mesocotyl that's essentially a taproot for times of drought. Has a really waxy leaf, and it's to limit evapotranspiration, and it's studied by plant geneticists all over the world. But one element that I'd like to highlight is their cultural integration with their resource scarcity and their style of agriculture. And one piece in particular is that they view those in their community that live the furthest away from the river, the furthest away from the spring, the most resource scarce as the most well-respected in their communities and the most reverent. And so although I'm not Hopi, I share some of that, and I come here today with that same respect and reverence for those that are on the front lines of resource scarcity. And it was through this resource scarcity lens, especially a water scarcity lens, that I stumbled upon insects as a potential solution to a lot of our water challenges in the desert Southwest. And I dissected it and looked at the viability of insects from that water perspective, just resource in versus resource out. And it made sense, and I certainly wasn't the first one to propose this, but the general conclusion of a lot of the research was that consumer attitudes would prevent this from being a viable agricultural product. And so this is where I decided to start the launch of insect protein, was with consumer perception and addressing this attitude. So before I launched a product, I looked at other industries that had started at this cultural perception level, and sea bass is an incredible example of an industry started around wild-caught sea bass, and we developed this identity for a premium value with sea bass. On the plate, actually blind taste tests show that most people can't tell the difference in taste between sea bass and other whitefish. There's no higher nutritional value, but we're willing to pay a premium for it. And because of this, because of the value at the consumer plate, it paved the way for the farming side of sea bass industry. Even though they're certainly not the most resource efficient fish to farm, they're blind when they're a juvenile, need live feed at that stage, and incredibly intensive fish to farm in retrospect. But because that value is at the consumer level, it paved that way. And that's what I tried to do with insects, and so create that consumer value as a pull-through demand for the supply chain. So I looked at it from that cultural perspective. The first thing I did was eliminate visual element of insects. I ground the crickets up into a cricket flour, and then added it to a very culturally identifiable food product. So we made protein bars. We made protein powders as well. Very, very nutritious and high in nutrients that you often don't get from a plant-based diet. People that are eating more environmentally conscious are often deficient in B12 and iron. And you may have trouble seeing it, but there's a little logo on the packaging. It's 1% for the planet. We became a member of that organization where it's for-profit companies donate 1% of their revenue towards nonprofit environmental organizations. And I did that not just to fund the efforts of our nonprofit partners, but because I wanted that to be embedded into the DNA of the company and of the message that we were communicating with the consumers, that this is a food product that's looking out for the future of our agriculture and our ability to feed our grandchildren. And I wanted to empower the consumer to make a purchase with that in mind and to engage them in the conversation about the future of our food. And it's started to work. Creating that consumer demand did create a pull-through for the supply chain. And this was our very first supply partner. This was a third-generation cricket farmer in the United States, one of our very first, and now there's dozens of them popping up all over the world. And so the hypothesis that if you build the consumer demand, the supply chain will follow is proving to prove out. And compare that to other countries around the world. Look at South Korea, for example. In 2014, they had less than 2,000 insect farms, and in only 3 years' time, they tripled that up to 6,000 insect farms. That was very government-driven, based on the foresight that the limitations of the rice economy due to climate change, they needed to reinvent their agricultural economy. And so they funded the growth of the insect farming industry, especially on the technology, but it outpaced the market. And so there's certainly a delicate balance to have between the market and the supply chain. And that's the dance we dance currently. I got into insects from just that purely resource efficiency, but it turns out that was just the tip of the iceberg. I think insects represent a fundamental solution to a lot of our biggest challenges that we face in agriculture, and really represent a glue to closed loop, more circular agricultural systems. For example, one of the biggest problems we have is food waste. It was touched on in our topic on the previous panel, but 40% of our food that we grow in the United States goes to waste, and globally that number's similar. It's about a third of all the food that we produce goes to waste. And the rotting of that food waste alone contributes 8% of our greenhouse gas. And so from that perspective, it's an incredible challenge that we need to face, and potentially one of the greatest that we can to address climate change. Then you look at the fertility of our soils. And the United Nations has predicted 60 years left in the fertility of our topsoil, which is a very scary outlook. So the marriage between food waste and soil is enter insects. Insects are one of the most diverse, one of the most successful animals on the planet. There's more than 1 million species of them, and they play a fundamental role in many of our ecosystems. And one of those roles is the bioprocessing of organic waste. And to really understand their potential for it, I think it's helpful to view the insect as not an individual species, but a capsule of an entire ecosystem of microbes that's developed for millions of years to work synergistically to process this organic material. And so when you take the waste and you feed it to an insect, not only do you now have a larva and a source of protein that just came out of waste, but you've also bioprocessed that organic material and inoculated it with a lot of these microbes that do things like break down cellulose and fix nitrogen, and you've created a much healthier soil that contributes to the viability of our topsoil. So this is what that looks like in real terms. This is me standing in front of a pile of palm waste that represents 1 million tons of waste in Indonesia with one of our producing partners. That was the palm kernel meal. So after the palm all the oil has been extracted, that was the meal that's left over. And these are the empty fruit bunches where the palm kernel comes from. And this material in particular is very high in fiber and cellulose and very low in nitrogen, a very low quality waste product that is usually just discarded or oftentimes burned. And so what happens in a natural ecosystem that's full of life and full of these microbes, et cetera, is that organic material falls, immediately fungus starts growing on it. It breaks down the lignin. Then insects take over, and you create this entire ecosystem around waste in a natural environment. And in a natural ecosystem, we don't even think about it in terms of waste. And so we're trying to replicate that biological system. So what we do is we take that palm waste, and then the first thing we do to the waste is we pre-treat it with microbes, bacteria and fungi, that are host-specific to this particular insect, meaning they're naturally occurring in that ecosystem of microbes. And when you apply that, it breaks down the cellulose, increases the nitrogen, and the crude protein content of that waste in less than a week's time goes from 2% to 14%. Then you add the insect, and the crude protein goes up to 40%. And again, this is just mimicking the natural ecosystem. And this is what the farm will look like. This is one farm that will, it's a 5-hectare facility, and it'll be able, there's 5 of these, and in total they'll consume 1 million tons of that waste and produce 200,000 tons of larvae per year, and reduce greenhouse gas emissions by 20 million tons. And this is it's a solar-powered facility, and it's developed right on top of the waste, so we're not having any carbon exchange in the transportation of that waste. It's all rainwater captured, so not using stored resources. And the concept is designed to be modular as well, and so we design these systems, and they're being designed all over the world right now, but design them around the piles of waste and the size of those piles of waste. So this is just a simple shipping container model that can be scaled around smallholder farms. And here's a couple of photos of one of the smallholder farms we're working with in Tanzania. And this is actually an orphanage where we've helped them build a black soldier fly farming operation that consumes all of the organic waste that they produce from their gardens. And then they feed that larva to tilapia. And so they're growing that tilapia on site at this orphanage in a closed loop agricultural model, and radically increasing the nutritional value of the food that they can produce on site. So the question remains, what is on our menu in the future in 2050? If you look at current trends, aquaculture is currently the fastest growing food producer on the planet, but it's also subject to falling under the same challenges that our current agricultural system that has prioritized short-term yields over long-term viability. And really the future of aquaculture needs to reside in more closed-loop systems. So the recirculating water systems, aquaponics, that need to have more of that closed-loop ecosystem designed to them, as opposed to the proliferation of a monoculture. And of course, last year was the first year in human history where we consumed more fish from aquaculture than we did wild caught. However, currently aquaculture is being propped up by fish meal from ocean caught sea life, and that clearly needs to change from a future of aquaculture perspective. And that's one of the main things that we're raising the insects for currently, is to support the replacement of fish meal in aquaculture. So insects are also on the map, aquaculture, insects, of course. And insects really, not only in and of themselves, but they really represent what's a much needed closed-loop, integrated, circular designed systems that really are conducive to localized agriculture. I get frustrated with some of the conversations that we have a little bit with this really binary, kind of linear concept of plant protein versus animal protein when we look at it from an environmental perspective. And certainly in a very basic understanding of photosynthesis versus heterotrophs, it makes sense, but not when we're thinking about full system design and integration, because these are just two of the pillars of life on this planet. There's several other kingdoms of life, and they represent an ecosystem that works with each other, and the interactions within these kingdoms of life are crucial to the viability of not only our agriculture, but life on this planet. And the smaller you go down, I think the greater the potential for addressing some of these large agricultural challenges we have in front of us. Leaning on that microbes again, we're at the just frontier of our understanding of their importance in human health, and of course in soil health. And you can't have plant protein without healthy microbial soil, microbial active soil. And so understanding the role of these in the future will be critical. And then taking it to the next level, the ability to grow microorganisms as edible microorganisms is an incredibly high potential field. There's microbes that photosynthesize, like cyanobacteria and microalgae, that can be grown without the same environmental constraints that you need for arable land, et cetera. And even next levels, currently there's some innovative projects right now taking CO2 out of the atmosphere and breaking that down to simple organic material that can be the substrate to grow these, and therefore you can grow edible microbes without even the need for photosynthesis processes. So I think that no matter what the future of our food and whatever is on the menu, one of the most critical elements that we have in front of us, and one of the critical tasks, is the communication of the science behind some of these food revolutions that we have. And the storytelling of this science is critical. And so from the challenge that I embarked on of the cultural challenge of introducing insects is simple storytelling. And stories are what make us up. That's what separate human beings from the rest of animals. And in fact, what is culture more than just the stories that we tell? And so whether we talk about the stories from the consumer down to the farms, or the farms up to the consumers, telling the stories of the future of our soil, of our water, and our food will be critical to the future of our food supply. And it's synonymous right now. It's overlapping with a consumer trend for a desire for transparency and wanting to see what is behind that. And our ability to communicate these stories to the consumer are unparalleled right now. Today alone on Twitter, if you were to make a book out of today's tweets, it would be 10 million pages long. The increase in blockchain technology to be able to communicate that is radically accelerating. And so a final thought on the storytelling of the future of our food, and kind of bringing it back to the Hopi culture, that one piece of their culture and their belief system is that their ancestors that have passed on, they call them kachinas, and they reside in the clouds. And in a very arid environment, when the clouds come, it's past ancestors that are bringing life to this generation. And the way that they call these kachinas is through laughter and through dance. And so even in the most trying of times, in the harshest of droughts, that's when it's most critical to be laughing and smiling. And that element of hope needs to be embedded into these stories that we tell of the future of our food. So thank you very much.